electricity. Okay, mostly see. So we have in India we have so many projects, large scale, medium scale, and small scale power projects. Okay, so this is one of the prestigious projects in our country. Okay, so to generate the power. Okay, electricity and hydropower. So let us see. So what is the importance of tunnels and caverns for this hydroelectric? Okay, uh, power projects. So we have so many projects. Okay, Thala hydro projects, northeast, Uttarakhand, mein. There are so many projects. Okay, so let us discuss the basics. Okay, so we have already studied this one. I think so. In our those civil engineers को जानता है. You know very well, na? You have studied this one, hydropower. हाँ, ठीक है. So you know the hydropower meaning the water is energy. Okay, it comes from the force of moving water. So the fall and flow of water is a part of a continuous natural cycle. So we are utilizing this natural cycle, water cycle. Okay, to accumulate the water, and then basically it's a one of the renewable energy source. Okay, so we can easily replenish. Okay, through rainfall. Okay, so here we have to drive the water under gravity, moving it from high ground to low ground. Okay, let us see. Hydroelectric power, often called as hydropower, is one of the important renewable energy source. Okay, so this is the see we are planning for the so we have a we are importing crude oil and all. So this is a costly affair. So it impacts on our economy. So we are okay minimizing this crude oil. Okay, so the petrol diesel rates are very high. Okay, so now we are okay hydro energy, hydropower energy. Okay, so this is one source that is not depleted in the production of energy. Okay, so energy is falling water is converted into electricity without using up the water. So the all basic. Okay, so basic idea is principle is kinetic energy. So it is while it is flowing of water, no, we are utilizing a kinetic energy. Okay, through turbines and all converted into this kinetic energy into electrical energy. Okay, so this is all of the hydro cycle, not hydro power to electric power. See this is the basically water head. You know the water head. Okay, so let us say it is a dam. Okay, so head water is there. So there is a there is a potential energy which is converted to, so we have to convert into the kinetic energy through a channel system, right? And we have to place a turbine here. Okay, it is generated by it is driven by a generator. Okay, so we can so mechanical energy convert, convert into mechanical energy into electrical energy. Okay, so this we have to connect it actually. So these excavations we have to prepare, so plan, design. Okay, the layouts, various sections are there. So in earlier days, let us say the same concept. Okay, utilized for the irrigation, for water wheel, irrigation purposes. Water wheel, if the water source is there, let us say. So we have attached the buckets. Okay, so at different along the periphery of the wheel. Okay, so if you have to rotate manually. Okay, so we can see the buckets will dips into the water, and it will carry the water, and you can transfer to the irrigation purpose. Okay, so this is the earlier days, the same concept we are utilizing. So here utilizing for the generation of electric power. Okay, the kinetic energy convert to mechanical energy through turbines. Okay, and then it will convert to the electric power. So the types of hydropower plants. First of all, the basics, and then understanding the basics, and then comes to the design part. Okay, so basically it's a power transforms the potential energy of a mass of water flowing a river, okay, with a certain vertical fall. That vertical fall is called as a basically head. Okay, water head. Okay, the cheapest source, they easily renewable. Okay, environmentally benign during running. Okay, so the potential annual power generation of hydropower is proportional to the head and flow of water. So this is the source basically. You have to generate the head and the flow of water. Okay, through rivers, dams. Okay, so the classification of power plants, hydropower plants, basically according to capacity, large scale, medium scale, small scale, mini, micro. Big. There are so many power projects in India. Okay, according to the head, the pressure, water head, the high head, medium, and low. According to the purpose, single purpose, multi-purpose. Okay, so according to facilities, runoff river, reservoirs, in-stream, pumped storage. So according to hydrology relations, the single, a cascade. According to transmission system, isolated, depending on the purpose and all the capacities. Okay, water head. Okay, so we are, see, let us say, according to capacity, the large scale means mostly 100 megawatt capacity. Okay, generation of the electric power. Okay, the medium 25 to 100 megawatts. Okay, so it is a medium scale. Small scale is 1 to 25. Okay, mini means 100 to 100 kilowatts to 1, okay, megawatts. Micro and pico, less than 5, it's a less than 5 kilowatts, the pico project. Okay, large scale project, medium scale project, like that. Okay, depending on the capacity of the power generation. Okay, so we have a, see the in all throughout the world. So we have small hydropower definitions in different countries. So depending on the capacities, so they have defined differently. Okay, let us see. See, Bhutan में देखिए, is less than equal to 25 megawatts. It is a, okay, small hydropower project. So less than or equal to 15, China, Pakistan, New Zealand, okay, Canada, US, it is a less than equals to 30. Okay, so like that we have to, okay, depending on the capacities. Okay, and depending according to the head, water head. Okay, let us see the 50-meter water head here. So in the figure I'm showing here 50 meters. Low head hydropower applications use river current or tidal flows of 30 meters or less to produce energy. The depending on the head, 30 meters, 50 meters, 150, 100, like that. Okay, so the first of all we need a dam or retain water to create hydraulic head. So you have to prepare, okay, create the hydraulic head by storing a storage of waters. Okay, so using the current of a water, naturally occurring tidal flow of create to create the electricity, we provide a renewable energy source. Okay, so the minimum head, basically a power station operating under heads from 30 meters to 300 meters. It depends. We have a small scale dams, large scale dams. Okay, so accordingly we have constructed the hydropower stations. Okay, so high head, a power station operating under head above 300. Because the medium head is 30 to 300. So above 300 is a high head. Okay, so you know the different components of a, say this is a reservoir or a dam. Okay, there is intake structures, and we have to construct this headrest tunnel. ये चाटी बोलते हैं. Okay, so and then there is a surge tank. Okay, so here we have to minimize. So this we have to design such a way that the water flow, we have to maintain that head actually, the kinetic energy. Okay, so which we are going to convert into the mechanical energy through turbines, and we have to construct some pens. Each has its advantages. I will discuss one by one. Okay, there is a pen stock. Okay, so here the construction details, design guidelines, then layouts we have to discuss here. Okay, and we have to there is another tail desk channel, and there is a powerhouse and powerhouse chambers to, okay, install all the turbines. Okay, okay, generators and all. So and then according to hydrological relation. Okay, so single stage, some cascade systems different. Okay, so when the runoff from a single hydropower plant diverted back to the river. Okay, so other than power generation, so it will be single stage. The cascade means when two or more hydropower plants are used in series. Okay, the runoff discharge of one hydropower plant is used as in the intake discharge of the second hydropower plant system. known as a cascade hydropower plants. Okay, the single use and multi, okay, hydropower plants. Okay, so the single purpose is the project is produce electricity when the project is known as a single purpose hydropower project. Multi-purpose, basically used for other purpose like irrigation, flood control. Okay, so multi-purpose hydropower projects. Okay, not only for hydropower, we can utilize for other purpose also irrigation, mostly the irrigation. Okay, and then according to the facility type, we can the runoff river type. Okay, basically it utilizes the stream flow as it rivers. So we have so many rivers. Okay, we have so many dams in our country. Okay, and then reservoir type. Okay, so you have to develop this reservoir by constructing dam across rivers. Okay, so pump storage type. Okay, so this is basically is utilize the flow of water from a reservoir at high potential to one at lower potential. Okay, so there is an upper pool reservoir and there is a lower pool reservoir. Okay, and in stream type. Okay, here we are utilizing this kinetic energy, the flow of steam. Okay, conversion into the electric power. This is called the in stream. Okay, so another transmission system we can use isolated connected to a grid like that. Hydropower is set up in a remote area in order to meet the local demands. So such power plant is known as isolated system. When the hydropower plant is set up to meet the demands of area which are a far distance from the plant, the transmission of power grid. Okay, okay. So we have a different projects. Okay, the two largest hydropower projects in the world, so 14 gigawatts, the type of project in Brazil. Okay, that okay. So one is in China, one is in Brazil. Okay, see the capacity. So these two projects produce 80 to 100 trillion. Okay, so 22,500 megawatts. Okay, so some companies are there manufacturing small turbines. Okay, so the research centers. Okay, so these are actually research centers basically works on the design and planning of design planning and construction of these hydropower plants. Okay, so all these issues, the construction of dams, okay, construction of hydropower tunnels, caverns. Okay, and we have an apex bodies, Indian National Hydropower Association, the Faridabad mein hai. Okay, and we have an alternate hydro energy center. Okay, and comes to the design. So now the terminology, what is the head dams? Okay,